Okay, 7.3 and 7.4 deal with adding and subtracting expressions. In the previous videos, we've multiplied and divided them, but now we're going to add and subtract them. Remember, when you add and subtract fractions, you have to have a common denominator. So they're going to start you out giving you a common denominator. So in this example, the denominators are the same, so you simply add the numerators. So when we do that, we end up with the numerator being 11x plus 22. So after you've done that, you want to see if you can factor either numerator and or denominator. In this case, we can factor both. So we factor 11 out of the numerator, and that gives us 11 times the quantity x plus 2. We factor a 5 out of the denominator, and that gives us 5 times the quantity x plus 2. These match up, they're all multiplied. So as long as we take matching numerator and denominator, we can cancel them, leaving our final answer 11/5. So that was an addition example. The next one will be a subtraction. So again, they give you like denominators. So all we have to do is combine the numerators. Now keep in mind this negative sign, it's distributed across anything that's in the numerator. So here, x plus 6 minus 1. The minus comes from the subtraction. So that leaves us x plus 5 over the denominator. So if we factor the denominator, we find that we have a numerator and a denominator that match, so we can cancel that. So our final answer is 1 over x minus 1. Now we'll go to one that does not have a common denominator. So 11 over 8x plus 7 over 18x squared. This denominator 8x is not the same as 18x squared. So it's kind of hard to tell by looking. So the easiest way to find the least common denominator is to take each denominator separately and break it into primes. So the 8 becomes 2 times 2 times 2. All the 2's are prime, and then it's also multiplied by the x. 18x squared becomes 2 times 3 times 3, and we have 2x's, x times x. So then our denominators, our factors are 2, 3, and x. What we have to do is take the most of each in either one. So let's look at the 2's. What's the most 2's you see in either this one or this one? So there's 3 of them in the first one, so that's more than the one here. So the most 2's in either of them is 3 of them. The most x's are 2 multiplied together in the second denominator, and the most 3's are also in this second denominator. So the most 2's times the most x's times the most 3's will be our common denominator. So it's 18x squared. So then we're going to take our common denominator, 72x squared, and divide it by each denominator separately. So we take the 8x, divide that into 72x squared, and we get 9x. So we got 11 9x's. So we have to take the 11 times the 9x. Then we take the second denominator, divide it into the common denominator. In this case, we get 4. and we got 7 fours, so we take 7 times the 4. So the 9x times the 11 is 99x, and the 7 times the 4 is 28. All over our common denominator, 72x squared. Now we'll take another one that does not have common denominators. So let's deal with our denominators first. 7x plus 7. We can factor out a 7 out of each of these, leaving us with 7 times the quantity x plus 1. We can factor 5 out of each here, leaving us 5 times x plus 1. So the next step is to find out what our factors are. So we have the number 7 and the number 5, and we have the quantity x plus 1, all our factors. So the most 7s we see in either one of these is 1. The most 5s we see in either one is 1. And the most x plus 1 quantities we see is 1. 1 in this one, 1 in that one. So all this multiplied is our common denominator, 35 times the quantity x plus 1. So that's going to go here. Then we take each denominator separately and divide it into our common denominator. So when we take our common denominator and divide it by the first denominator, the x plus 1s are going to cancel, and 7 goes into 35 5 times, and we got x number of them, so it's 5 times the x. In our second denominator, we divide that into our common denominator, and we're left with 7. 5, the x plus 1s cancel. 5 goes into 35 7 times, and we got x minus 2 of them, so it's 7 times x plus 2. So then we have a common denominator, and we can just add the numerators. So 5 times the x is 5x. 7 times the x here is 7x minus 14. Combine the x's, and we will get 12x minus 14 over our common denominator, 35 times the quantity x minus 1. Okay, the next part, building rationally equivalents. So 3/5 is equivalent to how many 35ths? Well, the easiest way to do this is to divide 5 into 35. That's 7 times, and we got 3 times the 7 for 21 35ths. And the last one here, they give you x plus 1 over x squared plus 6x, and they want you to find the equivalent to this denominator. So if we always start with the factoring, we can take an x out of these. Then we see that this compared to this means that we have an x plus 2 here that we've multiplied this by. So that means we have to multiply the numerator by the same x plus 2. And in both of these, you can see if you reduce the equivalent fraction, that means these would just cancel, and you would be right back where you started. Same way here, if you put 7 into 21, it'd be 3, 7 into 35 would be 5. So I'm going to stop here.